So, you've built an awesome Python program, right? But then you run it, you close it, and poof, all the data you entered is just gone. Well, today we're going to fix that. We're giving your Python scripts a permanent memory.
I mean, think about it. You write this cool script, it does its thing, maybe it asks for some input, and then it's over. All that information just vanishes. Your script basically has amnesia. Every single time it starts up, it's a completely clean slate. So how do we fix that? How do we give our programs a memory that actually sticks?
Well, the answer is a database. And the fantastic news is that Python comes with one built in, right out of the box. It's called SQLITE 3. What makes it so perfect for us is that it's serverless. All that means is your entire database is just a single file sitting on your computer. That's it. No complicated servers, no crazy setup. Super simple.
Okay, so we've got our Python script on one side, and we have our database on the other. But how do they actually talk to each other? They need a common language, right? And it turns out there's a universal standard for just about every database out there. And that language is SQL, which stands for Structured Query Language. Honestly, the best way to think about it is like this. If your database is a digital filing cabinet, SQL is the language you use to tell it what to do. You use it to file things away, to find things you've stored, and to keep everything organized. And you know, the best part about SQL is that the commands are just plain English words. They do exactly what they sound like. You use create to build a new table, insert to put data in, select to get data out, update to change something, and delete to get rid of it. It's really that straightforward.
So how do we use these SQL words inside our Python script? It's basically a simple four-step dance every time. First, you connect to your database file. Second, you create something called a cursor. Just think of the cursor as your hand. It's what you use to point and do all the actual work inside the database. Third, you tell that cursor to execute one of your SQL commands. And finally, and this is important, you commit your changes, which is just like hitting save. That's the loop for pretty much everything.
All right, that's enough theory. Let's see this in action. Let's actually put some code on the screen and build our very first database table from scratch.
Whoa, okay. Here's the full script. Now, don't worry if it looks like a lot at first glance. We're going to break this down piece by piece. The whole point is to understand what each line is actually doing.
Let's start right at the top. This first line, import SQLITE3, is super simple. It's just you telling your Python script, hey, we're going to need that built-in database tool I told you about. It's like grabbing the right tool from your toolbox before you start a project.
Now this next line, this is where the magic really starts. The connect command is so cool. It does one of two things. If a file named student_tutor_groups.db already exists, it just opens it up. But if it doesn't exist, no problem. It creates a brand new empty one for us right on the spot.
And this line right here perfectly shows the partnership between Python and SQL. See the cursor.execute part? That's all Python. But everything inside those triple quotes, that's pure SQL. We're literally telling the database to create a new table, which is kind of like a spreadsheet, and we're telling it exactly what columns it should have, like student_ID, first name, and all the rest.
Okay, great. We've built the structure, we have a table, but it's totally empty. So what's the next logical step? We need to actually put some information into it using our script.
Now this script looks pretty similar, but with one key difference. You can see we're using Python's regular input function to ask the user for their ID and their name. Then we use the SQL command insert_into to take all that information and pass it neatly into our table. Oh, and those question marks? They're just little placeholders, waiting for the data you type in to slot right into place.
So we've written the code to create the table, and we've written the code to insert data into it. Now for the best part, the moment of truth. Let's see it all come together.
Okay, here we go. We run the script, and look down in the terminal window at the bottom. It's prompting us for each piece of information. We'll just type in the details for a student named Jamie Oliver, and once we've entered everything and hit enter, and boom, this is it. This is the aha moment. We open up our database file with a little browser tool and look at that. Row number 3, Jamie Oliver, age 14, all the data we just typed in. It's there, it's saved. Our Python script now has a memory. It actually worked.
Now that you've seen exactly how it's done, it's your turn. Honestly, the absolute best way to make this stuff stick is to get your hands dirty and build something yourself. So here's a little mission for you. Using the exact same ideas we just went over, I want you to create a brand new database called Vehicles. Your table should have columns for things like the make, the model, the body type, registration, and fuel type. Go ahead and try adding a few of your favorite cars to it.
And that's really it. That's the foundation of using databases in Python. You can now make your programs remember absolutely anything, from high scores in a game you build, to a catalog of your favorite movies, to a workout log. The possibilities are literally endless. So my only question for you is, what are you going to build first?